Okay, so what we have in this question is two bodies, one of which is 400 newtons with a velocity of 8 meters per second and the other of 250 newtons with a velocity of 12 meters per second move towards each other along a straight line and impinge centrally. Find the velocity of each body after impact if the coefficient of restitution is 0.8. So we'll be using the conservation of momentum, that principle, as well as we'll be using the formula of the coefficient of restitution, right, as the initial velocity and the final velocities. So what is given to us here is weight is given, W1 I'll say is 400 newtons. So mass 1 will be 400 by 9.81, okay, that would be kg. W2 is 250 newtons, and similarly mass 2 will be 250 upon 9.81 kg. Okay, now the velocities are given, initial velocities are given. So 400 newton is having an initial velocity of, let me say this as u1. So this 400 newton is your first body, 250 is your second body, so the suffix will be accordingly. So u1 is 8 meters per second, okay, and u2 for this 250 newton is 12 meters per second. But now see what is given, they move towards each other. It means that if mass 1 is moving this way, mass 2 is moving this way, okay. So if this is the u1 along the right direction, this is u2 and it's towards the left direction, hence we'll have to take u2 as negative 12 meters per second. So I am taking this direction as positive, okay, and they are moving in a straight line. So they impinge centrally. It means that the line of impact goes through the center of mass of them. So these u1 and u2 are exactly, they are along the line of impact, okay. Let me just draw it in a better way here. Okay, so let's say this is the center of mass and the line of impact is going through the center of mass and they will be impinging centrally. Even the velocities are along the line of impact, okay. And what else is given? The coefficient of restitution is given, E is 0.8. Fine. So we do not know what is V1 and what is V2. V1 is not known and V2 is also not known. Fine. Now see, this is the x direction, okay. So we know that the momentum is conserved along the x direction, right. It's conserved even along the y directions, but here it's not moving in the y direction anyways. So first we'll apply that conservation of momentum thing. So I'll say conservation of momentum along x, okay. So that would be m1 u1 plus m2 u2, that is the momentum before collision, is equal to momentum after collision, right. So you see, this m1 and m2 are basically 400 upon 9.81 and 250 by 9.81. So but when we put m1 m2 on both sides, that 9.81 gets cancelled. So instead, in this conservation of momentum equation, we can also use the weights, okay. So even if we use the weights, you will get the correct answer only, not necessary for using the mass. So it is 400 into u1 is 8 plus 250 into u2 is minus 12 is equal to 400 v1 plus 250 v2, okay. So this will form one equation and we'll get 400 v1 plus 250 v2 is equal to 200. This is one equation that we get. Yes. What is the other equation that we can form? Second, the coefficient of restitution E, right. So E is equal to V2 minus V1, the relative velocity of separation divided by u1 minus u2, that is the relative approach velocity. So v2 minus v1 upon u1 is 8 and minus of minus 12 will be plus 12 and E is 0.8. So you will get another equation, minus v1 plus v2 is equal to 16. Okay, when we solve both of them simultaneously, we will be getting v1 and v2. So we get v1 equals to minus 5.8462 meters per second. That is the direction of the first ball or the first object. Since here nothing is given about that object, we would say that the first object goes to the left after the collision and v2 becomes 10.1538 meters per second to the right. So when the objects were first colliding this way, after collision this object will move like this, this object will move like this. Okay, let us solve next numerical. A ball is dropped from a height of h0 meters on a floor. Show that after first bounce it will rise to height h1 given by h1 is e square ho h0, where e is coefficient of restitution. Determine to what height the ball will rise after 3 bounces if dropped from a height of 2 meters if the coefficient of restitution is 0.8. So we need to understand that when the ball is being dropped on a floor, which are the two objects which are colliding with each other. So the first object is the ball, the second object is the ground. Okay, so these two things are colliding with each other, right? Now the ball is being released from a height of h0. So height is h0. Okay, what is the initial velocity of the ball? So the velocity of ball just before the impact, right? So for example, here I am releasing the ball from h0. Okay, and when it comes here in contact with the ground, what is the initial velocity of the ball? That would be u1, right? And how to calculate u1? We can say that, see, this is the final velocity. I mean the final velocity of this downward motion, okay? Not after the impact. This is not the final velocity after impact, but this is the final velocity of the downward motion. The initial velocity here is 0. Okay, so we can use the laws of motion and we can say that v square minus u square equals to 2as, right? So v is u1 square minus 0 square is equal to 2 into 9.8, or I'll say 2g into s, I'll say h0, and I am considering this downward as positive, so I am taking g as positive. So u1 is under root of 2g h0, correct? So u1 we understand it is under root of 2g h0. Okay, the velocity after impact of the ball is v1, which we do not know, which we have to find basically, right? Similarly, in the case of ground, what is the initial velocity? Initial velocity, let's say this is object 2 and this is object 1. So initial velocity u2, of course the ground is not going to move, so it's 0. Final velocity v2 is also equals to 0 because it's not going to move, right? Okay, so we have u1 v1, u2 v2. Out of these things only v1 is unknown, u2 and v2 are anyway 0. So what we can do, we can apply that coefficient of restitution, because we know let us just take a general value of E and find what is the equation that we'll get. So E is equal to v2 minus v1 upon u1 minus u2. v2 is 0 minus v1 upon u1 minus u2 under root of 2g h0 minus u2 is 0. Therefore v1 you will get as minus e root 2g h0. This minus sign indicates that it is upwards. You see that we had taken downwards as positive, right? So this negative sign indicates that v1 is going to be e under root 2g h0 upwards. Okay, so I am removing this negative and I am showing the direction of that velocity, and of course the units will put in meters per second. So what is h1? I mean, to what height it will rise after the impact, right? So after the impact, the ball is going up with a velocity of v1, okay, and it can go up till a height of, let's say, h1, where the final velocity will become 0, right? So again here we can use the law of the equations of motion. So final velocity, that is v square minus u square, equals to 2as. Okay, so now I am taking upwards positive. Okay, in this case I am taking upwards as positive because I am going to use this velocity as positive here. This is, mind you, this is the initial velocity. Okay, so this is the initial velocity of upward motion, that is after impact. Now the ball is going to move up, so this is that initial velocity. The final velocity is 0, so 0 minus e under root of 2g h0 the whole square is equal to 2 into minus 9.81, or let us write it as g only, minus g into h1. So h1 will be what? h1 will be e square into 2g h0 divided by 2g. This will get cancelled, therefore h1 is e square h0. This is what we had to prove, right? That h1 is equals to e square h0. Determine to what height the ball will rise after 3 bounces if dropped from a height of 2 meters. Okay, so see, this is when a first bounce takes place. In general, what I can say is that for a nth bounce, hn is equal to e square h of n minus 1. Okay, so like taking analogy from here, that h1 is equal to e square h0, so hn will be e square h n minus 1. Therefore what we can write is, for a second bounce, h2 will be e square h1, which is equal to e square into e square h0, which is e raised to 4 h0. Third bounce will be similarly, h3 is equal to e square h2, which is equal to e raised to 6 h0. Okay, so this is the height that the ball will reach in third bounce. We need to determine, if it was dropped from a height of 2 meters, to what height it is reaching. So h3, when it is dropped from a height of 2 meters, e is 0.8, right? E is 0.8, so 0.8 raised to 6 into 2, which is equal to 0.5243 meters. Okay, let us solve next numerical. So what is given is a 10 Newton sphere shown in figure is released from the rest when theta is 90 degrees. The coefficient of restitution between the sphere and the block is 0.7. If the coefficient of friction between the block and the horizontal surface is 0.3, determine how far the block will move after the impact. So we have the mu is given as 0.3, the coefficient of restitution E is given as 0.7. Okay, now what are the things that are colliding? This ball and this block, these two things are colliding. So we are interested into their initial velocities and their final velocities. So this is the ball and the block. Let us understand what is the initial velocity of the block just before impact. Okay, so how to find that initial velocity? See here, the velocity when the ball is at this point, the initial velocity is 0. Okay, when the ball reaches this point, we are going to get a final velocity. This velocity will be initial velocity for the impact. Okay, so do not get confused when I say initial velocity and final velocities. Here the initial velocity just before impact is what we are considering as u1. Okay, now how to get this v? That is when the ball is traversing from a height of 1.2 meters downwards. So this can be we can also solve it using the work energy method, where the work done is equal to change in kinetic energy. So work done is equal to change in kinetic energy. Work done is how much? The work done by the weight, 10 newtons downwards. So 10 into how much down it goes? It goes 1.2 meters down, is equal to half into 10 upon 9.81, that is half into mass into v square minus u square. V square minus u is 0. Okay, so v is what we want, right? This 10 will get cancelled. So v is under root of 2 into 9.81 into 1.2. It's under root of 2gh basically. So alternatively, you can also solve this using the potential energy and kinetic energy method. So the potential energy when it reaches down becomes 0, and kinetic energy is, it gets converted into kinetic energy that way. So that can also be done. However, okay, so u1 we have found as under root of 2 into 9.81 into 1.2. It is equal to 4.8522 meters per second. What is the initial velocity of the block just before impact? The block is stationary, so till this ball comes and hit it, the block is not going to move, right? So u2 is equal to 0. What is the final velocity of ball? We do not know. The final velocity of the block we do not know. Okay, so let us solve it. I'll be again using the conservation of momentum in the x direction and the coefficient of restitution formula. So the conservation of momentum in the x direction will be conservation of momentum in x direction m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1, so we have been given the weights. A 10 Newton sphere is there, and what is the weight of the block? Okay, weight of the block is 50 newtons. It's given here. So we can use 10 and 50. 10 into u1 we got as 4.8522. Now see, this u1 is basically in this direction. Okay, u1 plus 50 into u2. We do not know how. U2 is 0, right? Okay, u2 is 0 is equal to 10 into v1 plus 50 into v2. So we'll get one equation, 10 v1 plus 50 v2 is equal to 48.5222. Another equation we can get using the coefficient of restitution. E is equal to v2 minus v1 upon u1 minus u2. So v2 minus v1 upon u1 is 4.8522 minus 0 is equal to coefficient of restitution is how much? 0.7. Therefore we will get minus v1 plus v2 is equal to 3.39655. This is another equation that we have got. When we solve them simultaneously, we'll get v1 as minus 2.0218 meters per second and v2 as 1.3748 meters per second. So this v1, since we are getting minus, it's going in the right direction, and v2 is going in the left direction. So it means that after the impact, this is the direction of v1 and this is the direction of v2. I mean, the block moves like this and the ball moves to the rightwards. Okay, now we know that the block is going to move by this velocity. We need to know that how far the block will move after the impact. Okay, so again here we can use the work energy principle. We have the block here which is moving with a velocity of 1.3748. it's 50 Newton. The coefficient of friction is given as 0.3, so the normal N1 will be 50, and since the moment is going to be like this, the frictional force will be 0.3 times N1. Okay, and it will move a distance of s, let us say, and then it will stop, right? So the final velocity v, I'll say it is 0, and let's say this would be the initial velocity of the motion of the block now. So work done is equal to change in kinetic energy. Therefore we have to use this force, which is okay, so N1 is going to be 50 and this 0.3 into 50 is going to be, I think, 15 newtons, right? This is going to be 15 newtons. So what we'll get is, now the motion is in to the left, so leftwards I'll take positive. Minus 15 into displacement is s is equal to half m is 50 by 9.81 into v square minus u square, it's 0 square minus 1.3748 square. So s, when you solve this, you will get s as 0.3211 meters. So the block will move for 0.3211 meters after the impact. Let us solve next numerical. So what is given is a 100 Newton ball, as shown in figure, is released from the position shown by a continuous line. It strikes a freely suspended 75 Newton ball. After impact, 75 Newton ball is raised by an angle of theta equals to 48 degrees. Determine the coefficient of restitution. Okay, so the weight of this blue ball is 100 newtons. The weight of this ball, okay, this is also the same thing, it is 75 newtons. Okay, and it is being released from this position, what is shown here. When it strikes 75 newton, the 75 newton ball rises to an angle of 48 degrees. So we need to find the coefficient of restitution. So first of all, just before impact, see, this is the point where the impact is being taken place. So just before the impact, what are the velocities that we need to know? So I have a 100 Newton ball and a 75 Newton balls. Okay, the initial velocity u1 is, I have to find how much is that. So see, this ball, it is being released from this position and it is reaching this position. Okay, so what is the work done by the weight? The work done by this weight is by bringing this sphere or this ball down by this much height. So how much is that height? 3 meter is the length of the string. So this much height will be 3 minus 3 cos 60. It is equal to 1.5 meters. So this is 1.5 meters. Okay, so what is work done is equal to change in kinetic energy. Therefore this u1 I'll find that way only. So let us say this u1 is the final velocity reaching this position, and it is the initial velocity before impact. Okay, so don't get confused in these two terms. Work done is change in kinetic energy, therefore 100 into 1.5 is equal to half into m u1 square minus 0 square, because the initial velocity here is u is equal to 0, right? So u1 you will get as 5.4249 meters per second. Okay, so we found the initial velocity before impact of 100 newtons. What is the initial velocity before impact of 75 newtons? It is equal to 0, because 75 newton ball is at rest. Their final velocities we do not know, so we have to find them. Okay, these are the final velocities after the impact. So again I'll be using the conservation of momentum in the x direction, x. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 is 100 into u1 is 5.4249 plus 75 into 0 is equal to 100 v1 plus 75 v2. This is one thing. Coefficient of restitution we do not know, right? So fine, what we can do is, we cannot further actually like simplify this also. So now what do we know is that this 75 Newton ball, it rises by 48 degrees. So by how much meters it rises, what is the work done? Let me just draw that. So if this is your 75 newtons and it rises to this position, okay, this is 48 degrees. What is the length of that string? It is 2 meters. 2 meters. So how much has it risen? 2 minus 2 cos 48. 2 minus 2 cos of 48, which is equal to 0.6617 meters, and the weight is acting downwards. So if I want to apply the work energy principle here, that would be a negative work done by the 75 newtons. So work done is change in kinetic energy minus 75 into 0.6617, minus because the weight is acting downwards but the work is being done in the opposite direction to the weight. So minus 75 into 0.6617 is equal to half into m v. The final velocity here is 0. The initial velocity is v1, sorry, v2, not v1. I am considering this v2 like this to the right. So 0 square minus v2 square. So we can find v2 from this, right? So v2 will come out to be 3.60313 meters per second. Okay, so now I just have to put this v2 in this equation and I can get v1 also. Yes, so v1 I will get as 2.7225 meters per second. Okay, I guess the correction, the calculations is correct. Let me just cross check it once again. Yes, so we do get v1 as 2.7225 meters per second. Again, it means this direction only. So basically what is happening is this 100 Newton sphere, when it impacts with the 75 Newton one, both of their velocities is in the same direction. Okay, V1 is 2.7225 and V2 is 3.60313. So I guess we need to determine the coefficient of restitution. So E will be V2 minus V1 upon U1 minus U2. Therefore E is equal to V2 is 3.60313 minus 2.7225 upon U1 is 5.4249 minus U2 is 0. So E will come out to be 0.1623. So E is very less in this case. Alright, let us move to next numerical. So what we have here is two identical balls moving horizontally collide as shown in figure. Determine their velocities after impact if coefficient of restitution is 0.75. So we have now oblique impact here, as you can see, and in this case the velocities can be resolved into their components, and you will see that one of the component of the velocities is along the line of impact and the other component of the velocity is perpendicular to the line of impact. So the one which is perpendicular to the line of impact is not going to change, as we saw that. And see, okay, here nothing is given about the balls being smooth, but that is one assumption that we'll take here, that the spheres are smooth and they do not change the velocity in the y direction. Okay, because nothing is being talked about the friction between them as well. Fine. So let's say this is mass 1 and this is mass 2. So I'll just make a table here. We have the weights of both of them are given. Initial velocity in the x direction, I'll say u1x is equal to 6 cos 45. So I'm taking this to be positive. Okay, 6 cos 45, which is equal to 4.2426 meters per second. Okay, let me just simplify this diagram here. So we have 6 cos 45, or let me just write u1x and u2x. u1x acting like this and u1y acting upwards. Then we have u2x acting this way and u2y acting upwards. Okay, so u1x we get as 4.2426 meters per second. u2x will be that will be negative. This u2x is negative, right? So it's minus of 8 cos 30, which is equal to minus 6.9282 meters per second, and u1y will be equal to, and you need to understand that since there is no impulse acting along the y direction, the velocities in the y direction will remain same. So u1y is equal to v1y is equal to 6 sin 45, which will also be equal to 4.2426 meters per second and u2y is equal to v2y is equal to 8 sine 30. So 8 sine 30 is 4 meters per second. Both are upwards, right? So I'll apply the conservation of momentum along the x direction on equation we'll get from there. So m1 u1, now this time I'll write m1 u1 x plus m2 u2 x is equal to m1 v1 x plus m2 v2x. We do not know what is v1x and v2x, right? So it is 20 into 4.2426 plus 10 into minus 6.9282 is equal to 20 v1x plus 10 v2x. Okay, so we'll get this as 20 v1x plus 10 v2x is equal to 15.57. The next equation that we can get from this is E is equal to v2x minus v1x upon u1x minus u2x. Therefore E is given, which is 0.75. So v2x minus v1x upon u1x is 4.2426 minus 6.928, which will add up, so plus 6.9282 is equal to 0.75. Therefore we will get one more equation from here, minus v1x plus v2x is equal to 8.3781. Solving these two simultaneously, you will get v1x is equal to minus 2.2737 meters per second and v2x is equal to 6.1044 meters per second. So this negative implies that v1x is going to the left and v2x is going to the right, since it's positive. Okay, now our job is not yet finished here, because we have got v1x and v2x. We need to find the final velocities also. So v1x is this way, which is equal to 2.2737, and v1y, we know what is v1y, it is upwards and it is 4.2426, right? 4.2426. We need to find their resultant and we need to find at what angle it is acting. V, let us say it's v1 and this is the angle, I'll say it is theta 1. So v1 you will get as 4.8135 meters per second and theta 1 you will get as 61.8122 degrees. Similarly, v2 also we need to find. So v2x we know it is 6.1044 to the right, and v2y we know it is 4 meters per second upwards. So v2 is 9.284 meters per second and theta 2 will be 33.235 degrees. Okay, so what this means is that when these spheres they collide in this oblique manner, the sphere 1 will move in this direction with a speed of v1 and the sphere 2 will move in this direction with a speed of v2, and the angles are 61.8122 and 33.235 degrees respectively. Okay, let us move to next numerical. Okay, so what is given in this question is the girl throws the 0.5 kg ball towards a wall with an initial velocity va as 10 meters per second. Determine the velocity at which it strikes the wall at B, the velocity at which it rebounds from the wall if the coefficient of restitution E is 0.5, and the distance s from the wall where it strikes the ground at C. Okay, so the throwing action of this ball, although it looks like it is linear, but it cannot be linear because there is gravity also acting. So the throwing action of the ball is actually parabolic only. This VA can be resolved into two components. I'll say it is 10 cos 30 and 10 sin 30. Okay, now this 10 cos 30 component, which is along the x direction, it will remain same till it strikes the wall, but this 10 sin 30 component, it will keep on decreasing because the gravity is acting. And now you also have to understand that impact is happening between which two objects? The impact is happening between the ball and the wall, right? So we need to understand what is the initial velocity of the ball just before the impact is taking place. Okay, and after the impact is taken place, we will also understand what is the final velocity. So what I essentially want now is u1x and u1y, that is the initial velocity of the ball before striking, before the impact taking place. So how do we find that? We will resolve this velocity itself, which is 10 meters per second, and it is moving with a trajectory like this, right? It is having a trajectory of this way. So if I resolve this 10 into its components, individual components, it will be 10 cos 30 and 10 sin 30. This 10 cos 30 will remain the same as u1x here, but 10 sin 30 will change. So this I can say it is u1x. Okay, if we neglect the air drag, of course. So 10 cos 30 will be equal to, it is 5 root 3. Okay, and now what else we know? We know the distance from where that girl has thrown the ball. So it is 3 meters. We can find the time taken by the ball to reach this point B. Therefore 3 is equal to 5 root 3 into t. Therefore t is equal to 0.3464 seconds. Okay, we found how much is t. What we can find is the final velocity in the upward direction. So we know the initial velocity in the upward direction, it is how much? 10 sin 30. The final velocity will be, let it be u1y. And what is the acceleration that is acting here? It is downward acceleration is which is 9.81, negative 9.81. So we can use this formula as v minus u upon t is equal to a. Therefore v is u1y minus the initial velocity in the y direction is 10 sin 30 upon the time taken is 0.3464 is equal to minus 9.81. Therefore you will get u1y is equal to 1.6018 meters per second. Okay, so this is the final upward velocity with which the ball strikes the wall. What is the velocity of the wall? So u2x, now this we are writing for the wall. u2x is equal to u2y is equal to 0. The initial velocities are obviously 0, and also the final velocities v2x is equal to v2y is equal to 0. Okay. So what we'll get here is, so we have the initial velocity of the ball and the final initial velocity of the walls as well. We also need to understand that, see, because after the ball hits this point, it is coming back to the ground. So from what height it is coming back to the ground, that also needs to be understood. So at what height it is first of all reaching, that we have to calculate. So that would be the height that it is reaching. In the parabolic trajectory. So I'll say it is sy is equal to, we can use the formula of v square minus u square upon 2as. So v square minus u square upon 2a is equal to sy. Therefore it will be v, the final upward velocity is 1.6018 square minus 10 sin 30, right? 10 sin 30 square upon 2 into minus 9.81 is equal to sy. Sy will come out to be 1.14344 meters, and the total height from the ground will be how much? This much is 1.1434 plus 1.5 will give you the total height from the ground. So total height of ball is equal to 1.5 plus 1.14344 is equal to 2.64345. We can apply the equation of coefficient of restitution. So let us first understand what all things we actually now know about the ball. So the ball had started like this. It had a velocity of 10 cos 30 in the x direction, 10 sin 30 in the y direction. When it reached the wall, it is having a velocity of u1x, which is equal to 10 cos 30, okay, and an upward velocity of u1y, which is 1.6018. In fact, let us just calculate how much is 10 cos 30, because it's better to write that. It's 8.66025. okay, so 8.66025 is the this is u1x, and this is u1y. Okay, now considering that there is no upward impulse in the y direction, that is between the wall and the ball, we will consider that the upward velocity remains the same. So this u1y will get converted to v1y, or it will be not converted, but it will be basically the same only. There is no change in that upward velocity. This is just for simplification, okay. And this u1x, now when it bounces, when the ball is bounced with the wall, that u1x will become v1x, that is in the x direction, v1x, and v1y, we already know it is going to be in the y direction. So v1x is the only thing that we do not know, right? Otherwise everything we know. v2x we know, v2x is equal to v2y is equal to u2x is equal to u2y is equal to 0. These are everything of the wall, right? So obviously the ball is not going to have any velocity. So this coefficient of restitution is 0.5 here. We can apply the formula of coefficient of restitution. So 0.5 is equal to v2x minus v1x upon u1x minus u2x. Therefore 0.5 is equal to 0 minus v1x upon u1x is 8.66025 minus u2x is 0. Therefore v1x is equal to, we are getting v1 as negative, it means that the velocity is changing, right? So it is v1x is minus 4.3301 meters per second. It means it is 4.3301 meters per second to the left, right? Okay, so we have now found v1x. We can find what is the angle that the ball is going to make, because we know v1x and v1y also. So this is 4.3301 and upward velocity v1y is going to be equal to 1.6018, this one, right? 1.6018. So what is the actual v1 and at what angle it is making? So v1 will be, you will be getting v1 as 4.6169 meters per second, and the angle that it is making is 20.3 degrees. Okay, so it is making 20.3 degrees. Now again there is a parabolic motion here. You see that now this is our v1 this way, like this is the v1, and again it is going to bounce back, right? That is what is happening here. It is what is shown here as well. It is going to come down, and how much far it goes, that is what we need to understand. So let us draw the diagram again. So we have a ball here, and it is, after hitting, it is moving with a velocity of v1, and with a parabolic trajectory it comes down to this point. Okay, and the height, initial height of the ball is we had calculated that height just somewhere here. H is 2.6435. okay, so it is 2.6435. and we also know the x and y components of this v1, right? They are 4.3301 and 1.6018. okay, the ball is traveling 2.6435 meters down from its original point. So here we can say s is equal to ut plus half at square. If I want to apply this equation, it will be minus 2.6435 is equal to u. I am considering v1 only, because the movement we are considering in the y direction, right? So v1 is 1.6018 into t minus half into 9.81 into t square. Okay, so you will get t is equal to 0.9154 seconds. So it takes 0.9154 seconds for this ball to reach to the bottom position, to the ground position. Therefore, with this v1x, we can also understand how much far it is traveling, right? So sx, I will say, is equal to v1x into t, which is equal to, v1x is 4.3301 into t is 0.9154. it is equal to 3.964 meters, s1x. So that is what we had to find, right? S1x, I mean this s which I have taken as s1x. So that's it for this lecture. Till then, take care. Thank you.